Okay, we'll start today with the structure of material. We'll go with the introduction part, and okay, we will start. And this content is taken from the Professor M. Weaver, and the course name is MTE 271. You can also refer to his website. I will be just going through all his content. So now towards the introduction part. So these are the different pictures shown as example, showing that materials actually change the world. The way we see it, it's totally different from the last, like say 50 years, and before 100 year or before 150 years. So each day we evolve to a better world. We can see the development to the polymer, then glasses, optical fibers. We are having such a great internet due to these optical fibers. Then we have ceramic, which used as a subtle tiles, and which actually act as a thermal insulator barrier. We have a lightweight metals. We have a kelvar uh, for our bulletproof jackets and so on. So these are different materials which actually change the world. We see it. So how these materials are prepared. So that will be the one aspect, and this picture, this cartoon actually shows that uh, materials are the engineered structures. Now, let's say, for example, you have F-22 Raptor, and looking at their turbine engine. So, in the turbine engine, there's a disc and blade. Okay, so there's a high temperature. So to bear this high temperature, most okay, we need to design the material. We need to engineer the material. So in the service, these engineering materials get exposed to the high stress and temperature both. So the most close to have these structures are like single crystal structure. So first we developed the columnar structure, then we proceeded toward the single crystal structure. Now looking at the macro structure, you can see that actually it's a two different kind of material, but if we see the macro structure, they are actually coherent. Okay, so let's not go inside that, but the thing is that the whole body act as a single crystal material, and that's how we are actually prevent it from the failure. So, looking at the macro structure and property, so there are two main knobs by which engineers adjust the property of material, and that's the composition and microstructure. So, the composition part is the alloying part, like for example, like major alloying element and nomenclature. So, you have pure aluminum, which is written as 1 triple X, so 1322 or something like that. Then you have 2000 series, so that's copper. 3000 series, you have manganese. 4000 series silicon. 5000 series magnesium. 6000 series magnesium and silicon. 7000 series zinc, and 8000 series for another other light weight metals. But for like uh, steel is like most generally widely used material. So we have different nomenclature for that, like 1000 X, so it's plain carbon steel. 1100 X, it's plain carbon steel, but it is sulfurized for machinability, for better machinability. one 15 double X for low magnesium, like 15 to 20% magnesium. 40 100 series is for molybdenum. 50 or 4300 is for nickel. 4400 is for molybdenum. So this double X, what we are talking about is the weight percent of carbon multiplied by 100. So let's say you have 1060 steel. So 1060 steel, 10 so 1000, so it's a plain carbon steel, but how much carbon is there? So 60 by 100, so it's zero point 0.6, so zero point 0.6 weight percent of carbon. Okay, let's proceed further. So, how to engineer a desired microstructure? So, this is the main concern for everyone: how to engineer a desired microstructure. So, the desired microstructure is usually produced by some combination of synthesis and processing. So, obtain like we go through the combination of synthesis and processing part. So synthesis, like okay, processing, like for different material which actually undergoes a phase transformation. So processing changes the microstructure of the material. So let's say you have three different let me zoom this. Okay. So, what I can say right now, as CCT curve is not yet introduced, so this is the like TTT diagram, time, temperature, and transformation diagram. So, in this TTT diagram, these are the different, like three location, like from here, what will be the structure? From here, what will be the structure? From here, what will be the structure? So for three different part, what will be the structure that has been shown, and accordingly its mechanical properties compared with the cooling rate. So for this material, like it is cooled from very slowly at the high temperature only. So for the longer time it was at the high temperature. So there is formation of like aspherodite. So you don't need to like concentrate right now to the terminology, but the main thing you need to grasp is that there are different variety of microstructure that can be controlled that can be controlled with the cooling curve, so with the cooling rate. So we have low cooling rate, medium cooling rate, high cooling rate, and for those different cooling rate, you have different microstructure. So this particular concept is for steel right now. Then okay, and this is the processing part. Like we can do mechanical deformation, and this mechanical deformation will actually uh, the increase the strength of the material. So the question is, why is microstructure important? So the key part is that macrostructure actually alters the mechanical property of the material. For example, like its retail properties depend on macrostructure, and this is the example. You have three different microstructure or four different microstructure here now shown: one, two, three, and four. Yeah, this is the spheroidite one with the lowest cooling rate. This is at certain different cooling rate, let's say 8 something. This is 1000 something. Okay, and this is again high cooling rate. So what you can see that hardness of those different material are having different, sorry, not the different material, but processed through the different material that are having different macrostructure is having different hardness. So with the macrostructure you can actually alter the property of the material. So the so if you alter the processing, you get the different macrostructure and your property can be altered. So processing can be processing can change the structure. So structure versus cooling rate of a steel. Okay, let's look at the next one. So this is the journey. You have atom. So we'll discuss about some atomic configurations and all those. Then what are the different type of bonds that atom actually forms. So it will deal metallic, covalent, ionic and secondary. You must have grabbed all these in the 12th class. Then you have a crystal structure. After forming these different kind of bonds, what are the different crystal structure they form? You have hexagonal close packing, body centered close packing, face centered close packing, etc. So after discussing about the crystal structure, we will introduce different uh, parameters like Miller indices. What are the different how to read the direction in the crystal system, how to read the planes, and after discussing about the crystal structure, we will discuss about the phases. So we will learn about the different phase diagrams, what is the nucleation, what is TTT. Then we'll discuss about the properties like mechanical properties, optical properties, thermal property, magnetic, corrosion. So for the metallurgy part like mechanical and corrosion will actually have the lead in the studies. So we'll mostly discuss most about the mechanical properties and the corrosion part. So after discussing about the properties, we'll have the type of material and its application for the metals, application for the ceramics and the polymers and the composites. What are the different application like? Then the materials engineers tetrahedron where in this tetrahedron we have four different vertices. The first one is the processing. Like let's say if you want to use some material in certain application. So what are the different characteristics you need? So first you need to know about the what are the properties required. Once you know the properties required, you have to discuss about the structure of it. Okay, how the structure of the macrostructure look like. Then to get the structure, what are the different processing you need to perform, and after once you get for the different processing, you will get different properties, and these properties will actually tell the story about the performance in your application. So at the center you have all engineers. Okay, select or create material to solve the engineering problem. Okay, so the next time we'll look at the atomic bonding. Okay, okay, bye bye.